Hello everyone. So today we are going to cover sliding window for leftmost and rightmost part of array or string. Array or string. This could be anything. Okay. This could be array or it could be string also. So it could be array or string. Now what do I mean by this? This is actually very simple and easy and simple type of variable size sliding window. Okay, just you need to get the instincts like, okay, here I need to use the sliding window, this can be solved with the sliding window, and then you are done with it. Once you get that instinct that you need to solve it with a sliding window, you are done. Okay, these are actually very easy and simple type of whatever we have learned in the variable size, that only you need to apply. Okay, so what are the symptoms of it, if I can say? Okay, so how will you recognize this type of problems? So it can be said that you have to take some elements from leftmost and rightmost part of the array. What does this means? You can take from 0 to I, or and from j to n. Okay, you can take from 0 to I and from j to n only. So now we cannot apply sliding window on non-contiguous part. We have seen that sliding window will always be applied to contiguous subarrays. It was written almost in the every sub problems which we are solving, that sliding window will be applied on contiguous subarray problems or substring problems. Okay, now this is not contiguous, this is some 0 to I and some j to n. Okay, half part from the leftmost and half from the rightmost. So where we can apply the sliding window? We can apply the sliding window on the middle part, on the middle part. So what we have to do, we have to apply, here we have to apply sliding window on middle part, that is from I to j, and then whatever answer we will get, and then whatever answer we will get, subtract it from the total length, that is n minus whatever answer we have got, subtracted. That way you will get the actual correct answer. But how we have to do it? Now let's say in the question it's asked for find finding minimum number of elements from front and back of array. Now, from front and back, I mean that from leftmost and rightmost part of the array. So we have to find the minimum number of elements from front and back of array that can make a sum. Let's say sum of k. Then what we have to do? So we here in this type of problems, we need to apply sliding window on middle elements. Okay, and we need to find maximum length, because in original question it's asked for the minimum number of elements. So for the middle part, you need to do the maximum elements, you need to find with the maximum length, such that such that sum is what? Total sum minus k, total sum minus k, because k needs to be the sum of the front and back elements, then the middle elements should be the sum of total sum minus k. And for original answer we need the minimum number of elements, so for the actual answer we need to find the maximum such length. These are the two things which you need to take care of. So what you need to take care of, what you need to consider? Okay, take opposite of minimum or maximum length asked in question to apply sliding window on middle elements. This is the first thing, you have to do the opposite. And the second thing is make the calculation part. So if it is asked that for front and backward elements the count should be 2, then for the middle elements it should be total minus 2. Okay, that way you need to make the calculation out of yourself for the middle elements. For the middle elements, given given the calculation of front and back elements. I hope I'm clear with this. These are actually very simple type of problems. So without just wasting the time, let me just give you one example so that you can get the clear. Okay. Let us have one example. So let's say this is the array we are given 1, 2, 4, 3, 4, 3. Okay. And I'm making the sum as 3. So what do I mean to say? I mean to say that I want the sum as 3. Okay. I want the sum as 3, and my condition is from some elements of the front and some elements of the back. So from the leftmost and rightmost part of the array, I want the sum to be 3 with the minimum elements as possible, as minimum elements as possible. Okay. So what could be the option? I can take either this two, 1 plus 2, this is 3, this is also 2, true. But here my length or answer would be 2 because I have taken two elements. Or I can take this, which is just 1. You can take some elements from front and back combined way also. Okay. But it's not needed as per this question. I can take only this 2 and it can be done, or I can take this 3 and it can be done. So my answer could be either 2 or it could be 1, but my minimum answer could be 1. So now how we can solve it? By our way which we have learned. So what we need to do, we need to apply the sliding window for middle elements. Okay. And there the sum could be total sum. The total sum is 1 plus 2, 3 plus 4, 7, 3, 10, 4, 14, and 13, 17. 17 minus 3. So the middle elements sum could be 14. The middle elements sum could be 14, and that we need to find with the help of maximum length. So now you just find out 14 sum is possible with 1 plus 2, 3 plus 4, 7 plus 3, 10 plus 4, 14. So this way I can find the 14 sum. Okay. With 1, 2, 3, 4, 5 elements. So my answer could be with 5 elements. Or I can find the 14 sum with this also. 4 plus 3, 7. 4 plus 3, 7. 7 plus 7, 14. So but my answer could be with the 4 elements. But I need to find the maximum length. So I can simply apply the sliding window. We have already learned simple variable sized sliding window. Okay. So I need to find the maximum length. For the calculation, the sum needs to be 14. Okay. And my this length could be 5. Okay. So if I have got 5 out of this, maximum of this 2, I will take the maximum only. So if I get the 5 answer, so my original answer will be n minus 5. So n is nothing but 6. 6 minus 5, which is 1. So you get your answer. Okay. Let's just move to one of the question which we will be solving over here. Okay. So the question is given as you are given a string S consisting of the characters A, B, and C. Only these three characters and one non-negative integer K. Each minute you may take either the leftmost character of S or the rightmost character of S. You can either take the leftmost character of S or the rightmost character of the S. We need to return the minimum number of minutes needed for you to take at least k of each character. At least k of each character. So we need at least 2a, at least 2b's, and at least 2c's. Or return -1 if it is not possible to take k of each character. Okay. And we need to do this with the minimum number of minutes. So we need to take some amount of characters from leftmost and rightmost so that there are at least KAs, at least KBs, and at least KCs. Okay. So this is not the total number of count as sub-arrays problem. So this cannot go under the category which we have learned in the previous video. Okay. This is simple size related problems only. So we can directly do it with the simple variable size sliding window which we have already learned. Still it though be at least or at most, because that are related to count sub-array related problems. Fine. So the question says, so let's say in this type of question where we need to find two A's, two B's, and two C's. Okay. Let's just go over here. So let's say if I take from the front, so I can get 2A. Here from here I can get 1C. Let's say I have got 1B. Now I need 2B's. So if I take this, my 2B's category is over. Now I need to take 1C. I'm left with 2C's. Okay. I need to have 2C's. So what can I do? For 2C's, I need to go until this point. So if I'm going until this point and I'm taking this also, I need to take this also. This also I cannot ignore because I need to have two B's also. So I need to go until this point also. So there are total three from the front and 1, 2, 3, 5 for from the back. So my minimum minutes would be 8. So what I need to do? I need to do for middle elements. For middle elements, we need to find the maximum minutes. So only if we'll subtract that maximum from n, our total answer will be minimum. We need to find the maximum minutes. Minutes is nothing but the length over here. Okay, or I can say length in the simple terms. Maximum length such that how many, if k I need to do from the front and back, then counts count of a minus k I need to do from the middle, count of b minus k, and count of c minus k. This I need to take from the middle because I need to take k from the front and back as of my requirements. I need to have at least k. So minimum I need to have k. So I need ca minus k. Ca is nothing but total count of a's in the full string, total count of b's, and total count of c's. This I need to take from the middle, then only it could be possible. Okay, and they have also returned that return -1 if it is not possible to take k of each character. So my total count of a should be at least k, total count of b should also be at least k, and total count of c should also be at least k. If any of this condition falls, then our answer could be -1 from starting only. Okay, we need to have the total counts greater than equal to k, then only it can be possible to take k character. The worst answer will be to take the full string. Okay, but to take that also, if it is satisfying the condition, it's true. If it is not satisfying, there are no k characters available of any of the a, b, and c, we have to simply return the -1. So let's say I'm denoting the ca minus k as la, lb, and lc, or ma, mb, mc to be the middle a, middle b, and middle c. Middle a, middle b, and middle c, how many I need? So for this example, let's say I need two A's, two B's, and two C's. Okay, 2A, 2B, and 2C. So how many total A's? Let's say we count A. So our total A's are 1, 2, 3, 4, 5, 6, 7, 8. 8 A's. Our B are 2 only, and our C are also 2. So we need 6 A's, okay, 0 B's, and 0 C's in the middle. In the middle. Now this 6 A's could not be exact because here they have given at least K. So what could be this 6? This could be at most. This could be at most. Maximum 6 is only possible because 2 anyways I have to take from the front and back. So this could be at most 6 A's, at most 0 B's, at most 0 C's. At max, this much A's can only be possible in the middle. Not more than 6 A's could be possible in the middle. So these are my at most condition now. These are my at most condition now. So now what we can do for this type of problem? Okay, let's just solve it via the lead code and you will get it. Fine. So we will have our n as s dot size. So we will first try it over here. What we need to find? Maximum length. This is for sliding window. So middle part only. Maximum length for at most ca minus ka's, cb minus kb's, and cc minus kc's. Okay, so let's just first count the total a, b, and c. So let's say ca 0, cb 0, and cc to be 0. These are the total counts. I'm just checking if my s of I is a. I'll do this plus, else if it is b, I will do b plus, otherwise c plus, because there are only 3 characters available. So now if any of this is less than k, if ca is less than k, or cb is less than k, or cc is less than k, then we cannot proceed further. We need to simply return -1. Okay, now what is our requirement in the middle? So we need this to be ca minus k in the middle, cb minus k, and cc minus k, and this all needs to be at most condition, and that to maximum length. So remember the template for the maximum length in this case. Okay, we will just make it 0 again now, because we need to count it while we move in the loop also. So let's have our I and j to be 0, and our maximum length, which is of middle, let that to also be 0. So while j less than n, if s of j is a, what we will do? There was ca plus plus. Else if s of j is b, we will do cb plus plus, else cc plus plus. Now for the maximum length, if condition satisfies, so condition says at most. So if ca is less than equal to, what is ma? Ma is nothing but ca minus k. Now we have initialized the c's to be again 0. Okay, so let's just remember that. So if it is less than equal to ma, cb is also less than equal to mb. Okay, so condition satisfies, everything needs to be satisfied. Okay, and cc is also less than equal to mc. This means our condition is satisfied. So our this thing could be, this answer could be maximum of whatever we have got, and j minus I plus 1 needs to be our updated length. Else what we will do, while I less than equal to j and condition does not satisfies. So condition does not satisfies, either ca greater than ma, or cb greater than mb, or cc greater than mc. So this is condition not satisfying. If this is the case, we will remove from the I part. So if si is a, we will do ca minus minus. If si is b, we will do cb minus minus, else we will do cc minus minus and I plus plus, because this is the normal case now. Again, we will check this condition. If it is satisfying, we will just update our answer as maximum of g minus I plus 1, and we need to do g plus plus here also. Here also we will do g plus plus. Okay, fine. So we are done with this. So our answer will be what? Original answer will be n minus whatever we have got this maximum length, that we will get the minimum answer, which is asked minimum number of minutes. We will return that. Clear? I hope I'm clear. These are actually very simple and easy type of questions. Okay, which could be asked in your online assessments or first level of interviews. Fine. So I'll be providing you the notes and the extra questions for this type of question, similar kind of questions like what we have learned in the description. Okay, I do want one favor from all of you. Just give me a comment down below, like which topic do you want next after sliding window. Okay, as the placement drives are going on, whoever is watching, I request you to please give me some suggestions on what you want next after sliding window. Okay, otherwise I'll go as per the schedule which I have prepared. For the next video on sliding window, I'll be going to cover prefix, suffix plus sliding window, which are actually very hard level of problem, usually asked in top MNC companies at last round of tech interviews. So stay tuned for that.